November 1812, the frozen battlefield of Krasnoi. A young French officer lies bleeding in the snow, left for dead during Napoleon's disastrous retreat from Moscow. Russian soldiers find him alive. They march him 600 miles to a prison camp on the Volga. And there, in the freezing cold, without books or notes, working entirely from memory, he will invent a new kind of geometry. Last time, we met Joseph Fourier, who conquered heat with infinite series of sines and cosines. We saw how the orphan from Auxerre became Napoleon's Egyptian administrator and eventually unlocked the mathematics that runs our digital world. Welcome back to Men of Mathematics. Today, we meet Jean-Victor Poncelet, the prisoner of war who invented projective geometry, one of the most beautiful and surprising branches of mathematics. Poncelet was born in Metz in 1788 and studied at Monge's École Polytechnique. He learned geometry from Monge himself, the master of descriptive geometry who had trained a generation of French engineers. He became a military engineer in Napoleon's army, building bridges and fortifications. In 1812, Poncelet joined Napoleon's Grande Armée for the invasion of Russia. After the burning of Moscow, during the catastrophic retreat, his unit was destroyed at the Battle of Krasnoi. Poncelet was wounded and left for dead. Russian soldiers found him alive and marched him 600 miles through the Russian winter to Saratov, a town on the Volga River. There he would spend 18 months as a prisoner of war. In his prison cell, without access to any books, Poncelet decided to reconstruct geometry from first principles. What he created surpassed everything he had learned. Working entirely in his head, Poncelet filled 7 notebooks with geometric discoveries. He developed the core ideas of projective geometry, a new way of looking at space that would transform mathematics. What is projective geometry? It studies properties that remain unchanged under projection, like the shadows cast by a light source. Consider how railroad tracks appear to meet at the horizon. In ordinary geometry, parallel lines never meet. In projective geometry, they meet at a point at infinity. Poncelet's key insight: treat points at infinity just like ordinary points. Add a line at infinity containing all the points where parallel lines meet. This seemingly strange addition creates a more symmetric, more beautiful geometry. Every 2 lines meet at exactly 1 point. Every 2 points determine exactly 1 line. No exceptions, no special cases. What stays constant under projection? Not distances. They stretch and shrink. Not angles. They distort. But the cross ratio of 4 collinear points is preserved. This single number is the fundamental invariant of projective geometry. Projective geometry reveals a profound symmetry. Any theorem about points and lines has a dual theorem where point and line are interchanged. 3 points are collinear becomes 3 lines are concurrent. Points lie on a line becomes lines pass through a point. This duality shows that points and lines are, in some deep sense, the same kind of object. One of Poncelet's most beautiful results. If a polygon inscribed in one conic and circumscribed about another closes, then starting from any point gives a closed polygon. This theorem connects geometry to algebra in surprising ways. After Napoleon's abdication in 1814, Poncelet was released. He returned to France with his 7 notebooks and published his masterwork, Traité de propriété projective des figures, in 1822. Poncelet used a principle of continuity. If a geometric property holds for one configuration, it should hold as the configuration varies continuously, even through impossible intermediate states. Cauchy, the great rigorist, attacked this principle as unproven. Poncelet defended his geometric intuition. Modern algebraic geometry has vindicated much of Poncelet's approach, though with more careful foundations. Poncelet proved a remarkable result. If you have one circle with its center marked, all compass and straight edge constructions can be done with straight edge alone. The compass becomes unnecessary. One circle is enough. After his mathematical work, Poncelet turned to engineering. He designed an efficient water wheel, wrote influential textbooks on industrial mechanics, and served as commandant of the École Polytechnique from 1848 to 1850. Jean-Victor Poncelet created projective geometry in a Russian prison cell, working without books, reconstructing mathematics from memory. His geometry of shadows and perspectives revealed deep symmetries hidden in ordinary geometry. The cross ratio, the principle of duality, points at infinity. These ideas transformed how mathematicians think about space. There's something deeply moving about Poncelet's story. Left for dead, marched through the frozen wilderness, locked in a foreign prison. And his response was to think, to create, to build something beautiful in his mind while his body suffered. Mathematics can be done anywhere. It requires only thought. As E.T. Bell wrote, Poncelet was one of the most original geometers who ever lived. His work was the starting point for one of the major developments in 19th century mathematics. Next time on Men of Mathematics, we meet the greatest of them all since antiquity, Carl Friedrich Gauss, the prince of mathematicians. Child prodigy, perfectionist, genius in almost every field of mathematics. His motto, few but ripe. The next 3 episodes explore his world. Thank you for joining us on this journey through mathematical history. If you're inspired by mathematics created in the most difficult circumstances, subscribe and hit the notification bell. New episodes release every week. I'll see you next time.